Hey folks, welcome back. So we've done a lot with these tools so far, and you've got a lot of different, formulas. I call them tools because that's what they are. You just got to know which tool to pull out of your tool belt to solve the problem. But sometimes we're going to have to be combining a whole bunch of things, and sometimes the units aren't what I need them to be. And that's what you're going to find out this week, because this week on the second lesson, you're going to figure out how what the density of the planet is. So remember how we talked about how if it's made out of rock, then it's a terrestrial world. That's good. That's something that we could have critters walking around on. If it's mostly kind of slushy ice, well, that's not going to be good. That's going to be like Neptune or Uranus, or it could be a gas giant like Jupiter and Saturn from that. The only way that I can tell what it's made out of, whether it's made out of gas, ice, or rocks and metals, that is to figure out the density. But that means I'm going to have to be doing a lot of conversions because up to this point, we've been using things like astronomical units, solar masses, solar looms, things like that. Sometimes I'm going to need that actually in watts, or I'm going to need to convert from Earth masses into grams. I'm going to need to convert from Earth radii into meters or centimeters, even in this case. So the number is the same, but the units need to be different. And we've done this a little bit when we've been converting like between Earth masses and Jupiter masses and things like that. But we need a more general way so that I can look at any conversion that I ever need to do and I can change those units. Because if you don't get your conversions right, people can die. I mean, in my field, I am an astronomer, but I was also a former NASA engineer. And what you may not be aware of is that NASA actually killed a spacecraft because they didn't do their units correctly. The Mars Observer spacecraft, perfectly healthy, 10-month journey to Mars. It arrived at Mars and it was supposed to aerobrake. Now, what aerobraking means is it extends its solar panels and it kind of dips down into the atmosphere. The Martian atmosphere then hits those solar panels, slows down the spacecraft, and it goes into orbit. It's a really great technique because I don't have to fire any engines to go into orbit from that. And so all that mass that I saved from the fuel that I had to carry then can go into science instruments and things like that. So it's really important. Unfortunately, the contractor who worked on the navigation data didn't use the same units that the spacecraft was expecting. So instead of aerobraking, the spacecraft lithobraked. Litho means rock. It smashed into the surface of Mars, $2 billion spacecraft, absolutely destroyed because somebody didn't get his conversions correct. This also happens on Earth, though. When my daughter was a baby, she had a very, very high fever. We took her to urgent care. The nurse misread milligrams as micrograms of Tylenol. And so she gave her a 1,000 times dose of Tylenol to this little 8-month-old baby. Well, that can cause kidney failure. So she almost killed our daughter because she didn't do her conversions correctly. So think about it. Sloppy engineers kill people, sloppy doctors kill them faster. So don't be killing any innocent baby spacecraft. Make sure you get your units right. So to do that, we're going to give you a step-by-step procedure for doing any conversion. And I've been doing this for 20 years. I fly spacecraft using this procedure. You may have your own method for doing conversions. Humor me. Do it my way for this semester. After this semester, you can do it however you want, but I can almost guarantee you're going to do it the way I'm going to show you now. Because basically, with my job, when I was flying the space shuttle, when I was sending out navigation data for the space shuttle, if I did my job wrong, if I messed up a conversion, people are going to die. So I had to figure out a way to get it right every single time without making a mistake. Well, nobody's going to die if you get this wrong, but you might fail a test. And you probably don't want that either. When you're panicked, and you're nervous and you're trying to do a test, you want to be able to be sure that your method is just going to basically do it robotically. It's just going to take care of it. So that's the method I'm going to teach you today. So we're not going to do any science today. It's strictly going to be learning this method of conversions. And I want you to do it this way every time. Actually write it out. All right, let's get started. Okay, so when we want to convert anything, we always need a conversion factor. So that's nothing more than saying these two things are the same. So for example, 24 hours equals 1 day. Those two things are the same. Would you agree 24 hours and 1 day are the same thing, right? So what that means then is all we're doing is we're converting the units. 24 is not the same as 1, but 24 hours is the same as 1 day. It doesn't have to have a 1 in it. It often will, but it doesn't have to. So, but anytime I've got two things that are equal to each other, that's my conversion factor. So let's suppose that you want to run a 5 kilometer race. And that's a pretty common distance for a race. Does anybody know? Think about it. Do you know how far that is in miles, roughly? It's about 3 miles, somewhere in there. So, but we want to figure out exactly how far it is. So let's say I want to run a 5K race, but my treadmill only measures in miles. Well, I need to know exactly how many miles, because, if I'm off by, even a little bit, that's going to change my estimate of my time for running that race. So I need to convert 5 kilometers into miles. How many miles is 5 kilometers? So I need my number to convert, which in this case is 5 kilometers. The next thing I need is my conversion factor. This will always be given to you. It's on your equation sheet. Every conversion factor you will need for this class is on your equation sheet. Now, you can use this technique for anything, though. All you need to do is go look up a conversion factor, and you've got it. So in this case, 1 kilometer is 0.621 miles. Look at that. That equal means these are the same thing. 1 kilometer is the same thing as 0.621 miles. It's not a formula. It's a conversion factor. Lots of people refer to this as a formula. It's not. You can't do any calculations with this. This is just saying, hey, dummy, these two things are the same. And you may say, well, 1 is not the same as 0.621, and you're right. But 1 kilometer is the same as 0.621 miles. So here's my conversion factor that I've pulled out. All right, so anytime you're going to do a conversion, I want you to write it out, physically write it out on your paper this way. I actually physically write it out. I've been doing this for 20, 25 years, and I still do it this way. So here's the procedure. 4 easy steps. So take what you want times a fraction bar. So you see I've got 5 kilometers times this fraction bar, and I've got spaces for my units here. And then over here, this is what I want. So what I want times a fraction bar. Now I take my conversion factor here. I want to get rid of the kilometers, right? And I want to be left with miles. So I'm going to put one of these units in the top and one of these units in the bottom. If I want the kilometers to cancel, where do I put it? Well, it's got to go in the bottom. You don't even have to think about it. You say, well, I need one in the top and one in the bottom. If my units were in the bottom, I'd put it in the top. So I want my kilometers down here, and that means my miles goes here. You see that? So first thing, so step 2, always take your conversion factor. Don't worry about the numbers. Just do the words. I want my kilometers to cancel, so I put kilometers here and miles here. All right, so that's step 2. Don't even think about numbers. You're going to get lost in the numbers, so just kilometers cancel. Now, for step 3, I put the number with the unit. And these things are glued together. They can't come apart. So the 1 has to go with the kilometers. The 0.621 has to go with the miles. And so it looks like this. I can't have 1 mile and 0.621 kilometers, right? Because they're glued together. Now step 4, do the math. You see that my kilometers are going to cancel. I'm going to be left with miles. That's good. All you got to do is multiply by everything in the top, divide by everything in the bottom, hit equals. So I would do 5 times 0.621 divided by 1. Pause the video, figure out what that number is. Now you may say, Kilo, why am I dividing by 1? That didn't change anything. That's true, but this number won't always be 1. So you may as well get in the habit so that you never have to think about it. Multiply by everything at the top, divide by everything at the bottom, hit equals, and you're done. So 5 times 0.621 divided by 1 then gives 3.11 miles. So it's actually a little over 3 miles that I need to run. If I'd been training for just 3 miles, I actually wouldn't be running far enough. And so I would be underestimating my time for the race from that. So to see how that works, now this procedure works for anything. So for most of the rest of the lecture day, we're just going to do some examples so that you can learn how to do these conversions. And then towards the end, I'm going to give you the conversion that we're going to end up using with density. Okay, so imagine I want to know the mass of Jupiter, which is 318 Earth masses, in grams. So I need the number to convert. Well, Jupiter is 318 Earth masses. Earth masses is a unit. And I want to convert that to grams. So I need a conversion factor. So you look on your equation sheet, and it's got the conversion factor. The conversion factor is 1 Earth mass is 5.97 E27. Remember, that's how you put that in. 5.97 times 10 to the 27 is 5.97 E or EE or EXP 27 grams. It's not an equation. It's not a formula. These are just saying, hey, dummy, these two things are the same. That's it. All right, let's set up our problem then. We take what we want times a fraction bar. So I've got 318 earth masses times a fraction bar, and I want grams. I want the earth masses to cancel. So step 2, just look at the units. Look at the words here. Which one goes in the top? Which one goes in the bottom? I want the ME to cancel, so I'm going to put the ME at the bottom and the grams in the top. Do you see why? So step 1, write down what you want to convert times the fraction bar. Step 2, look at just the units. ME cancels. Now, step 3, these numbers are glued to the units. So the 1 has to go down here, and the 5.97E27 goes up here. Now I'm writing this way. Remember that E might be an EE button or an EXP button on your calculator. Do it your way, but don't do times 10 to the 27. So step 4 then, the final step, multiply by everything in the top, divide by everything in the bottom. 318 times 5.97E27 divided by 1. You see my MEs cancel. I'll be left with grams. That's good. Pause the video, work it out. All right, so you take your MEs cancel, all that's left is grams, that's good. So you take 318 times 5.97E27, divide by 1, and you get 1.90 e to the 30. 1.90 times 10 to the 30 grams. Let's see if this makes sense. So 1 gram is about the mass of a paperclip. How many paperclips do you think there are in Jupiter? Oh my God, huge number, right? So you had be better getting a huge number. And here I'm getting 1.9 and another 29 zeros going out behind it. So that looks good. Make sense? If you didn't get that, pause the video, go back, do it again. All right, let's do another one. Let's say I want to convert from grams to earth masses. So I want to go the other way. So here my grams is 8.66 E27. My conversion factor, not an equation. It's the same one. One earth mass is 5.97 E27 grams. So step 1 is what? Write down the number times the fraction bar. 8.66 E27 grams times the fraction bar. Step 2 is what? Put your units in here. I want grams to cancel. Where do I want it? I want the grams in the bottom this time, and so my ME is going to be in the top. Step 3, what is it? Step 3 is these numbers are glued to their units. So the 1 goes with the ME, the 5.97 E27 goes in the bottom, goes with the grams. Check, my grams cancel. That's a win. So step 4, multiply by everything in the top, divide by everything in the bottom. That needs to be E27, by the way. Okay, go ahead and do it. And you should get 1.45 earth masses. All right. If you didn't get that, pause the video, go back through and do it again. Again, this is 8.66 E27. The little exponent here didn't print. All right, let's have you do this one yourself. Let's say I've got 2.8 earth masses, and I want to know how many grams that is. So I want you to do all 4 steps from the beginning. Pause the video, work it all the way to the end, and then we're going to come back and look at it again. So pause the video now. All right, so you back? Got the answer? Let's go through the steps. Step 1, write down your number with its units times the fraction bar. Step 2, look at the units. Don't worry about the numbers, just look at the units. Grams and ME. I want the ME in the bottom so that it cancels. Step 3, put the number with the unit. It's glued to the unit. So the 1 goes down here, and the 5.97 E27 goes here. Check. My MEs cancel. That's good. Step 4, multiply by everything in the top, divide by everything in the bottom, and you should get 1.67 E28. See if this makes sense. I've got a planet that's all over twice the size of Earth. I want to know how many paper clips it's made out of. Better be a big number, right? Okay. All right, now this isn't just with grams and earth masses. We can do this with anything. So I want you to test yourself. Let's say that I've got a star here that is half 0.45, I'm sorry, 0.54 solar looms. I want you to figure out how many actual watts that is. Remember, a watt is a unit of power. So the sun is one solar loom. The sun is putting out 3.827 E26 watts. Now you tell me how many watts is this particular star, this 0.54 one? And you might say, well, kilo, I could just multiply by 0.54. I get that. But what I want you to do is get used to using the conversion, because sometimes you multiply and sometimes you divide. And that's where people mess up, is if you forget to multiply if you multiply when you should have divided, you're going to get the wrong answer. If you set it up this way, you don't even have to think about it. It's always going to work, and it's always going to give you the right answer. All right, pause the video, do this one from the very beginning. Let's see how you do. All right, you got it back? Let's go through it. Step 1, write down that number times the fraction bar. Step 2, get your units to cancel. So I want the L sun in the bottom, I want the watts in the top. Step 3, the number is glued to the units. So the 1 goes in the bottom, 3.827 E26 goes in the top. Step 4, so we check. L sun cancels. Good. Multiply by everything in the top, divide by everything in the bottom, and we get 2.07 E26. 2.07 times 10 to the 26 watts. If you didn't get that, as always, go back, work it out. If you still can't figure it out, come by live help. All right, so for your practice then, you're basically going to be getting a bunch of these conversions to do. If you've got the technique, actually shouldn't take you very long. So go through the conversions, make sure that you're getting them. Come by live help, let's check your answers. Let's make sure that you're getting the right thing. But if you're following this procedure step by step, and what I suggest is just have the video running while you're trying to do this. Follow the procedure step by step. Eventually, you're going to have the procedure memorized, and it's just not going to let you down. It's always going to work. And when you're trying to keep people in space alive, that's a good thing. Okay, so now you know how to convert from one number to another, from any unit to any unit that you ever need to do. If you're making a spreadsheet, what you're probably going to want to do is you're going to want to have multiple columns anytime that you need to have the same number in a different unit. So for example, if you need the luminosity in solar looms, you'll have a column, star luminosity, solar looms. If you're going to need it in watts, though, you want a separate column that says star luminosity watts. This is why when I'm labeling the top row of my spreadsheet, I'm always putting the units in parentheses, because just having the star luminosity isn't going to help you if you don't know, is that star luminosity in solar looms or is that star luminosity in watts? Is that mass in grams or is that mass in earth masses? So when you're working with your spreadsheet, it's a good idea to go ahead and label those columns with the units so that you can find it. If you got any questions about that, just come by live help. We'll get you set up. We'll see you next time.